Well, welcome back. This section will be dealing with measuring dielectric of these pucks. So we will end up testing pucks A, B, and C, and this process will result in the necessary data to be able to export dielectric values for these production mix material sample pucks. Thank you. So the first thing you'll want to do for successful puck dielectric testing is make sure you have the necessary equipment. So to begin with, we have the PaveScan antenna. That's what you all know are these sensors that we use to actually send the signal into the puck. You'll also see here, this is our stand to set the sensor on. And one thing I'd like to mention here is that this is all for RDM 1.0. There will be some changes for RDM 2.0, but we'd still like to take you through the steps of RDM 1.0. So keep that in mind as we're going through this process. The next thing you'll want to make sure you have are the actual production mix material sample pucks. And what we have here is our design void, low air void sample. We labeled that A, and this will be familiar to you from the video from 2.1 explaining how to fabricate and label the various samples. This is puck B, and this is puck C, our highest air void puck. So we have the necessary samples that we'd like to test today. So now we want to make sure we have our materials to assist us with the testing. One of those being our metal plate, as well as two separate Delrin spacers. And you'll see how these come into play later during the testing process. We also have our various cables. We'll only actually need two cables for this test, where this is the cable that we use to connect our orange box, which will be black for the RDM 2.0, to our tablet for this test. And then of course we also want to have our cable that's going to connect our sensor here, in this case sensor number 24, to our box. And we'll show you how that connects here in a little bit. So we did briefly discuss that we also have our tablet here. This is the same type of tablet that you'd have in the field. And then we have our battery packs, which are used to power up the orange box. And with that, that brings us to our concentrator box here, which again is the same as what you have in the field, where we'll be connecting to the tablet and then also to sensor number 1. So that's the setup that we'll use to do our dielectric measurements. All right, so now we're going to start connecting some things here. So we're going to take our battery packs, and these battery packs are interchangeable. They're actually hot swappable. So it can operate with just one battery attached at a time, but not suggested. But that does allow you to swap in a new battery when you're in the field, if you're out there longer than the amount of time that the batteries can last. But we're basically just connecting these batteries as we would for our field collection. And now we'll move on to connection of the tablet cable. We actually label our tablets, or I mean our cables, so we know which end goes where, but it's pretty self-explanatory with this cable that this is going to be the one that goes into the tablet, and then this is the one we're going to show you how to connect now. There's some tabs in here, but the way we remember it is this little knob here goes towards the back. And one thing you want to know is if you're trying to push too hard with these connections, you probably have it in the wrong spot. So you just want to kind of gradually slide it in there, and once you see it kind of lock a little bit, then you can twist it to put it in place. So the last cable we're going to connect with this end of the box of the connection is our cable that's going to connect to our actual ground penetrating radar sensor. And this, again, the tab is going to be facing on the back, and what you'll want to do is make sure it locks in place there, and then once it's locked in place, it should just tighten up there as you normally would screw anything in. So now we're going to connect the other side of these cables, and the first thing we'll do is connect our GPR sensor here. And to allow for the measurement process, you actually have to weave this through here and then rotate it. And at this point now, we're going to be able to connect this sensor so that it's ready for measurements. So what we'll do now is take this cable here that we previously connected to the orange box, and now we're going to connect it to our GPR sensor. And what we do here is again look at this tab, and in this case we're actually going to have that tab facing the GSSI emblem. We're going to next move on to our tablet connection. And this sensor looks like this, or end of the cable looks like this. And on this one, you actually have to line up this little tab that you probably can't see on the video. But again, this is the same connection you do in the field, where you just kind of twist this around until it gets to the spot where it's gonna latch in there. And it might take a couple times where you actually have to look to see where that little hole is. And again, you don't want to force anything, you just be patient with it, and you see how that locked in, and now at that point you can twist it until you have a good connection here on your tablet. What we're going to do is we're just going to power on our concentrator box here. You'll see the blue light illuminated there, and then also we're going to want to turn on our tablet here, which is just okay. This is the process of setting up your file. So we're going to press collect here, and the first group is your route number underscore project identifier. For us, that's state project 7906. But what we're going to do now is show you how to create a new project. So by pressing new project, it'll say transfer current project information to new project. Normally we would say okay, because we are in that project again, but for illustrative purposes, we're going to actually do the whole new project and show you how to enter this information. So we're going to start with new group. And our new group name is going to be TH, because we're on Trunk Highway 61 underscore SP 7906. Accept. Now we're going to go into our project name, and we are going to enter 061. That indicates our route number, underscore pucks, underscore the date of paving. So in this case now, we have it written on our puck that this was paved on 9/17/2019. So we're going to put 09-17-19. We're going to select one sensor, and location. This information is not necessary, it's just for bookkeeping. Materials and Road Research Lab. Lane edge is fine. We'll select left side. Again, this information is unimportant. And then equipment operator, I'm going to put my initials, K, E, H. We'll press save. And this will bring us to our detecting sensors page, as we've seen previously, where we see that we're using sensor 24, and this will be the sensor we use for data collection. So now once the sensors are warmed up, we actually still have to go through the calibration process, even though this data isn't actually used for anything. Of course, this will change when we have the puck testing module. But what you'll do here is just press the air calibration, even though, like I said, this data doesn't actually mean anything. It's just to allow us to get into collection mode. And the same applies for our metal plate calibration, where again, once that turns green down there, we're doing our metal plate calibration, even though there's actually no metal plate being measured. And this process is just done to allow us to collect data. Okay, so now we've done all of our inputs. So what you see here, again, as the most important indicator for us is our test summary sheet number, or whatever identifier your state uses to keep track of your samples, and a dash and an A. And this A corresponds to which of the production mix material sample pucks that we're actually physically testing on this operation. So here you see A indicated on this puck. This is our design puck. This is our lower air void puck that you'll be from data. So to do that, we're just simply going to press collect data. And that's going to get us into our data collection screen here. It's going to be a series of 4 15-second measurements, and the first one will be simply with the 2 Delrin blocks placed on top of the sensor. This is equivalent to our air testing from the field, where we're using this to eliminate some of the background noise. And now once I press collect time, it's going to be collecting continuously for 60 seconds. So we're just going to work our way through the process here. So once we have our Delrin in place, and I think we're ready to go here, we can press collect time. And this is going to give us a nice 15-second count here, where we know once this number hits 15 seconds, we're on to the next step. Okay, so now we're ready to do the metal plate test. And you actually have a little bit of wiggle room with these tests, where it's actually the last 5 seconds where the measurement is done. So after it hits 30 seconds, now we're going on to the puck testing portion. And once that hits 45 seconds, then we're going to move to the metal plate on the top side portion. And this is going to complete our measurements. Once this hits 60 seconds up here, we're going to be able to scroll down and just stop collecting. And at that point, you've collected all the necessary information you need to be able to extract dielectric from the puck. Okay, so now that we've tested sample A, we're going to move on to test sample B, which is our medium air voids puck. In this case, we're going to want to indicate that we've changed to sample B by going into the to that space, and now we're going to give it a dash B. And I'm doing this upside down here, but we should be able to enter B here and accept. So now what you see here on the file root name is our test summary sheet number dash B. And again, that indicates the actual sample that we're testing. Once we've finished entering the file root name with the -B at the end, we can go into collect data, scroll down, oh wait a little bit here, and we're going to go into collect time. And you want to make sure that you have your Delrin spacers, 2 Delrin spacers in place before this hits 10 seconds, because between 10 to 15 seconds, that's when it's doing the measurement of the Delrin spacers. So we've hit past 15 seconds, so we're now going to do the metal plate portion. And this is going to collect between 25 and 30 seconds, and then we're able to remove the metal plate and put our puck B sample in place. And this is going to get its measurements between 40 and 45 seconds. And then once that hits 45 seconds, we'll be able to finish our measurement process with the metal plate on top. And that's going to collect between 55 and 60 seconds, and once that hits 60 seconds, we're going to scroll down and press stop and save. Now we're ready to test puck C. So to be able to properly indicate that in our software, we're going to delete B and enter C and accept it. So now you can see here our file root name is 60431, our test summary sheet number, -C, and we'll press collect data. This brings us into our data collection screen, where we're going to want to scroll down and press collect time. And now you can see this count up going here, where again between 10 to 15 seconds it's going to be collecting our 2 Delrin samples. This is equivalent to our air calibration test to get rid of the noise. And once that hits 15, now I can start with the transfer, so that now we're getting our metal plate test. And this one is going to collect between 25 to 30 seconds. And again, once this hits 30 seconds, I'll be able to remove this, place our puck C in place, and this is going to collect its data between 40 and 45 seconds. And once that's completed, we can do the transfer, put the metal plate on top, and this will be collecting between 55 and 60 seconds. Once that hits 60, we can scroll down, press stop and save, and now we have a low, medium, and high air void content dielectric measurements. Now that we've completed the actual testing process, let's export the data. So the first thing we'll do here is go back to our main menu, and we're going to go into playback mode now. And you see here we have our project group that we set up earlier and our project name that we had set up associated with this set of pucks. And we're also going to select a file from here just to make sure we're in the correct data set. So now that we know we're in the correct data set, we can actually export this entire project. So we'll do that now. And you get a pop-up that says exporting to project folder. Once this up here is complete, it'll give you an export complete, and now you know you're okay to exit out of the program. So we're going to actually go to the main menu here, and we're going to exit out of our program, and we're going to go through the process of exporting the data using a USB stick. And once we have that in, we now see this is the location of the root of the USB stick where we will be pasting data. So the next step we'll do is actually open the File Explorer. So we're going to open File Explorer, and the first thing we'll do is go into Documents, open. And we're going to go into PaveScan RDM exports, open. And I like to organize it by date modified because that's always the one that you just exported. So we're just going to simply take this and copy it into our USB stick, and now we know this is the folder associated with the data we collected. This specific sample was paved on 9/17/2019. And we'll actually open this up now because that's where we're going to paste the raw data next. So in order to grab the raw data that is actually processed with the MATLAB algorithm, we're going to go into Documents again. We're going to open up RDM files. We're going to go into the raw data. For this, you can open your DZT files folder, sort by date modified, and you can see that there's data here corresponding to the current date. We're going to go through the steps if you make a mistake in the middle of your measurement and you save the file on accident. So 6043-A is an error measurement here. So what we'd like to do is go into our playback like we showed before, but now instead of playing back the file, we're going to go into File Properties. There's not a delete functionality with RDM 1.0, but the workaround for this is to go into that file name and delete it. And you can put any file name here. I like to just call it junk, just so we know this is a file that should not be used for analysis. And by doing that and saving, we can go back into our main menu, and next time we go into playback, that file name will now be junk, and when we end up exporting the data, it will be correctly identified.